in the previous lecture we have seen that what is non-destructive testing and why do we need it. So before moving on to discuss specific non-destructive techniques in terms of their theory and application, firstly, it is important to have a clear understanding about the distinction between a non-destructive testing and destructive testing. So here you can see the picture on the left hand side demonstrates the process of non-destructive testing, whereas the picture on the right hand side demonstrates the process of destructive testing. So as its name suggests, in destructive testing there is a failure or fracture of the component which is being tested. So if we have to see the NDT and DT in terms of their definition, so let us start with non-destructive testing. So as we have already discussed that non-destructive testing is kind of inspecting technique in which material, component or assemblies are tested or inspected for any crack or flaw, such that after the inspection the serviceability of the part is maintained. Means after inspecting you are able to use that particular part, there is no failure or fracture of the component. Whereas the destructive test technique, if we have to define it, then it is a process for finding out properties of the material, where the material being tested gets damaged and cannot be reused for the test. Means you have a material, you make particular type of sample from the material and you perform destructive test in order to find out the properties of the material, and after that test you cannot use the same material to perform the test again. So the material gets damaged either by failure or there can be a fracture. So failure means if the particular material is not able to perform its specific task, then that is known as failure. And fracture, if there is a breakage or of part in one or in two or more parts, then that particular phenomena is known as fracture. So if we have to compare the non-destructive testing and destructive testing, then we will discuss firstly we'll discuss the specific points about non-destructive testing. So non-destructive testing, it's used to find out the defects of the material. In this test, load is not applied on the material, although in some cases it is applied, like in acoustic emission testing, but generally we consider that there is no load application in most of the NDT techniques. There is no chance of the material damage. We do not require any very specific and special instruments. So NDT is a non-expensive technique. We generally require less skill for NDT techniques, and examples include visual inspection. Likewise, we have to inspect the component with our naked eye, or we can use some other optical aids such as magnifying glass, optical microscopes and other techniques to enhance the perfection of the visual inspection. Then there's a dye penetrant test where we use a colorful dye in order to reveal the cracks, and magnetic particle test uses the principle of magnetism in order to have indications of the cracks on the material or the component. Whereas in destructive testing, you can see here is a sample. It is a cylindrical dog bone shape sample which is used to perform the tension test. Means this tensile force is applied on this specific on this sample, and after the test you can see there is a fracture in this sample. So destructive test, if we have to discuss some specific points about it, that it is used to find out the properties of the material. Load is applied in destructive testing, material gets damaged in this testing, very special equipments are required for it. So we discussed in the coming slides what are those special equipments. and it is a expensive technique and skill is required. Means when you are getting the data should be analyzed thoroughly, and you should have some theoretical knowledge also in order to analyze that data. And examples include tensile test, in which a tensile force is applied on the specimen. Tensile force means the force which whose effect is to produce extension in your test specimen. Then there's a compression test, hardness test, etc. So one important point about destructive testing is that as it is performed on a specific type of sample made up of a particular type of material. So suppose you are having this mild steel specimen which is tested under tensile loading. Suppose you have to make another complex shaped component which is made up of mild steel, then it is not necessary that the tensile testing will give you a clear indication that how that complex shaped component will perform when it is subjected to uh, the particular type of application for which that component is designed. So it is not necessarily always the case. And here this slides also compare destructive and non-destructive test techniques. So the NDT methods can be divided into these specific techniques such as visual inspection, liquid dye penetration where we use colorful dye, magnetic particle inspection uses the principle of magnetism, eddy current testing uses the principles of eddy currents which are circular currents, ultrasonic testing which uses ultrasonic waves, radiographic testing use X-ray in order to produce X-ray images. Likewise, we humans do the x-rays of a body in order to find out some fracture in bones and all. So similar type of studies performed in non-destructive testing. In acoustic emission testing, the elastic waves which are released from the stress from the cracks on the application of external stress is known as acoustic emission testing. There's impedance based testing which sometimes use piezoelectric materials, and there are advanced methods which nowadays involves the fiber optics, machine learning and lasers. In destructive testing, which is the major focus of this lecture, so destructive testing includes the tension test. Here the tensile force is applied. In compression test, see the specimen is getting compressed. In shearing means if one half of the component slides over the another half of the component, then that process is known as shearing. Here the force applied is parallel to the cross sectional area. So here you can see these red arrows are parallel to this cross sectional area. So this is a shearing action. In torsion, so the you are rotating the your specimen. In bending, the specimen is bending. And in buckling, so these buckling generally occurs when there's a axial load is applied, and that axial load generally uh, produces a type of bending, but that generally occurs in, or most of the time occurs in, the vertical column. So and for vertical column this bending is denoted by the term buckling. There are some tests like hardness test. This is this is our sample, this circular disc type sample, and this is our penetrant. So you can see this is a sharp tip of the penetrant. This just creates an impression of the tip on the sample, and by measuring the dimensions of that impression you will calculate the hardness of your sample. And there's a fracture toughness testing. Here you can see this is your sample. Here you create a small crack which is also known as notch, and when you apply the load, likewise I am drawing with this arrow, two from upward side and one from the downward side. So when you load this material in this way, then what happen, there is a fracture in the material, and due to this fracture we will have a stress strain diagram, and from that stress and strain diagram we calculate the fracture toughness. And this is a fatigue testing. Here you can see this heated region, so this is the sample. Actually this is the image which shows fatigue testing at higher temperature, means specimen is subjected to higher temperature inside its chamber and it is subjected to cyclic loading. So this is a fatigue testing. So these are the type of testing which we generally study in when we study about mechanical properties. So if we have to find out mechanical properties, then the tests which are performed are known as destructive tests. So in order to perform destructive testing, so the most versatile machine which is used is universal testing machine. This is a modern universal testing machine. This is how this machine looks like nowadays. So this is our environmental chamber here. So you can slide it back and forth, and inside this environmental chamber you can see these are the arrangement of grips. These grips are for tensile test. So this is our sample here. So the bottom one is fixed and the top grip is movable, and you can perform tension test here. So this device, you can see this is an extensometer which is used to measure the strain. So here this crosshead is movable, and this upper grip is attached to this crosshead, and bottom one is fixed to the base of this machine. And these are the samples. With this can be flat shape, this can be cylindrical, and here you can see these are the tests which is performed on a brittle material and ductile material. So you can see that there is a breakage in the component during the testing. So this is known as the destructive testing machine. And the fatigue testing, the creep testing, tension, compression, shear, bending, all the tests can be performed on universal testing machine at room temperature as well as higher temperature and low temperature. So for low temperature you use a liquid nitrogen supply in this environmental chamber, and that maintains the low temperature. And for maintaining higher temperature there is a heater coil which is in there inside this chamber. So if you have to perform your study at higher temperature, you heat that coil, and due to that coil the temperature of your specimen changes, and you can perform your test at any particular temperature. And this slide shows the various equipments used in non-destructive testing. So here you can see a magnifying glass which shows the visual testing, the colorful liquid sprayed which shows the liquid dye penetrant testing, and here you can see the magnetic particle inspection, where this is a handheld device. It has a circular coil in it where the current is supplied in the coil, and it will produce magnetic field which is uh, which generally make its contact with the sample. And this is eddy current inspection. Here this probe makes eddy currents, and that gives us the indication of our any flaw or crack in the sample. So this is ultrasonic testing. Here this sample generates ultrasonic waves. Here you can see this is a metal sheet. So when these ultrasonic waves travels inside the material, when they come into contact with any cracks, so their path changes, and due to which you can get indication on your screen. And here is the acoustic emission testing. In this testing what happened is we subject the component to external load. Those external loads are very small, and due to those external loads, if there is crack inside the material, the crack releases energy, and that energy is detected with the help of some specific sensors, and those gives us idea about the presence of cracks. So we can easily detect that from which location we are getting this signal. So this is a X-ray radiographic testing. So this is a portable instrument. It is you can get an X-ray image of this component. You can see that whether there is internal crack or flaw in that material. So this I have shown you. Radiographic image of an welded joint has been shown in the previous lecture. If you have not found if you're not seen that lecture, you can go back and see the lecture where I've discussed the radiographic image of welded joint. So advantages and limitations, if we have to see, then firstly, advantages of destructive testing, that it is direct and reliable. It gives a quantitative measurements, means it gives you a value about your measurements, and there is a correlation between test measurements and material properties. Likewise, the when you are performing a tension test, you will get the value of this force and displacement, so that will gives you a clear relation between your material property and those force and displacement value. And limitations means tests are not performed on the objects directly. You need specific type of samples to perform destructive testing. A single test may measure one or few properties. Likewise, for the aluminum specimen, if you have to measure its tensile strength, compressive strength, and shear strength, you need different samples and you have to perform different tests. In service, testing is not possible. Destructive testing is not possible when the component is in use. Preparation of test specimen is costly because every type of specimen every test has specific requirement of specimen shape and size. Time requirements are high in it. And if we move on to non-destructive testing, then its limitations are that it is indirect, reliability is to be verified. It gives mostly qualitative, that okay, crack is present, but what are the, it will not give you exact information about the cracks. In some cases with advanced instruments it do give, and then you need skilled judgment and experience in order to interpret the indications, and sometimes new technicians may miss the discontinuity, which can lead to severe failure. So advantages are that these are performed in actual objects, so this is a very important and crucial point here. So, and many methods can be applied on the same part. Likewise, you can use liquid dye penetrant testing, magnetic particle inspection, eddy current testing. It depends on your expertise, that what kind, and your interest, that what kind of technique you want to use. And the other one is that if you are aware that the crack will be subsurface or surface, then according to that, means either the crack is present on the surface or deep down the surface, based on that also you need to select the entity technique. In service, testing is possible. Little preparation of is sufficient for entity test, and these tests are generally rapid. So I hope you have got a clear indication and idea about the destructive testing and non-destructive testing. Thank you.